data analysis with the help of pandas data frame, and how you can use this data frame to perform various analysis. It's a simple analysis. So that is first case study. Second case study is about how statistics can be adopted for data science. So different statistics we discussed, right? Two basic statistics, descriptive and inference. How you can use this descriptive and inference statistics to perform analysis. In that context, we are going to consider the data taken from public school in Middle Tennessee. So this is a place under southeastern part of USA. So this is second case study. And third case study is about heart disease prediction. How you can use machine learning algorithms, different machine learning algorithms for heart disease prediction, for which I took Cleveland heart disease data set, a very popular heart disease data set used by many researchers. That's why I considered and plan to discuss under this data set. And fourth one is about unsupervised learning with k-means clustering. So these four case studies I have planned to demonstrate in the afternoon session, and followed by the one which I have said, right? COVID data, how WHO used COVID data to perform various analysis, and trending analytics using Google trending. How Google used trending analytics to perform various analysis. In that context, we are going to discuss. So let me start with first case study. So here it is about to perform various data analysis, for which pandas library is used. And in pandas you have data frame. Data frame is basically a two-dimensional representation. Means it is a primary data structure used in pandas, which is used to represent two-dimensional format, like a tabled format with heterogeneous form of data. Heterogeneous data collection in a tabled format, you can able to do your analysis, and it is mutable data structure. So here four kinds of analysis we are going to perform. The data set for which the data set which we are going to use for this discussion is US President data set. So four types of data analysis we are going to do. One is analyzing the president based on their occupation, and president years in office, and what is the minimum age. By this we'll come to know, let's say, which president, US president is with minimum age, and also how many years they were in the office. So that way we can do this analysis, and we can use even plots, visualized graphs to analyze their occupation, by which we can understand which percentage of, let's say, or which, how many presidents are under which occupation. That way we could do analysis, and popularity wise also we can do. So for that, let me take this data set, which is US President data set. So this I'm going to, I have opened here in my system. I'll open and show you. So this is that data set. You can see that the list of presidents right from George Washington to Barack Obama, the last or the former president of USA. So where it includes several parameters in this data set, like number of popular votes, means total number of people has casted their votes, national total votes, total electoral votes, rating points, to which political party they belong to, what is their occupation, in which, let's say if they have studied, in which college they studied, let's say percentage of electoral and popularity. So this is how the data set is available for this US president data set. Now with the help of this data set, we are going to do our analysis, like the one which I have said. The first one is about analyzing the president based on their occupation. Again, let me stop sharing this Excel sheet and open the programming environment. The programming environment which I used in my case is Spider. You have several tools available, but in my case I've used Spider for my analysis. You have PyCharm, you have Jupyter, you have even IDLE. So you have several tools available. But here, what I have used is Spider. You can use any other tool on your convenience. Now, first we are going to see the president based on their occupation. So for that, I have used the data set. So this is the link where I maintain my data set. President dot in an Excel sheet I maintain, so I have referred the extension of that, where I'm going to read this Excel file, and PD is a reference taken for pandas library, and then you are going to store, of course, as a data frame. As he said, data frame is a two-dimensional representation which can include heterogeneous information, not necessary that all the parameters should be of same type. You can maintain different data type parameters in every column. Now we are interested only about occupation. So if you look at the Excel sheet which I said, there is a column called occupation. So I'm going to extract only that occupation. Only from that occupation I'm going to extract and I'm going to display. So for example, here you can see DF refers to data frame, and I have referred to that particular parameter occupation. So if I execute this, where it extracts and displays, you can see in the console, which is at the bottom left corner of the screen. So you can see that it has listed the president along with their occupations, right? So you can see that lawyer, businessman, actor, soldier, engineer, educator, lawyer, and so on. So now you can see that you can extract, let's say, and you can see the president based on their occupation. So this is a very simple analysis. So if you want to extract a particular field where you can refer this way and refer the field name, and by which you can extract and you can get the some list of that field contents. So now let us move to second form of analysis. So you are going to, let's say if you want to do your analysis in terms of how many years that president was there in that office, and what is the minimum age, or which president with a minimum age has, let's say, hold that post. So if you are supposed to do that, then you have to, of course, extend this code like you can see here. So the same data frame I have used where from pandas I have extracted this data frame and I'm going to use this. I can see here that I have used these fields, years in office, where I'm looking to get which president has, let's say, in that post for minimum or what is the minimum time and maximum years and sum. So these are predefined functions available, and these predefined functions can help you to get the minimum value, maximum value, and sum. And you can also observe that I have used one more parameter here, age at inauguration. This is also one of the field in that data set, age at the inauguration. So this is about the first, this is the first parameter, the age in which, let's say, he has taken that post. Right. So this is an extension of the previous code where the predefined methods like min, max, sum has been used, where referring to that particular field and using this method, when you invoke this method where it will try to get minimum, maximum, and sum. Now I'm going to run this. Now this has generated an output in the console. So this execution has generated 4 output. Minimum, president year in office. Let's say one president was only for 6 months, and maximum is 12 years, a president with 12 years, and total means sum of all the years of all the presidents. And a president who, let's say, into that post is with a minimum age is 43. So likewise, you can also use this and also get the maximum. What is the maximum age? Let's say, for example, max is a function. Likewise, you have n number of functions. You can see that I have extended with max, where you can also see the minimum age and maximum age. Maximum age is, of course, 69, and minimum age is 43. So this is how you can do various analysis, and you have several inbuilt function supported here, and by which you can perform different analysis like this. Now, let us get into third analysis. So third analysis is about plot using plot to plot based on the occupation. So based on the president occupation, if you are interested to do that, where you are supposed to, let us say here, of course, I have written the code already, as it may not be convenient to write the complete code at the time of demonstration, where I have placed this code in different files and I'm explaining now. Now you can see here that I have used the same file, US President file, a data set consisting of that US President details. And here you can see that I'm going to plot this. So where I've used matplot for this. So matplot is one which I have used for this. And you can also see here that I have used a pie chart. So I'm going to use pie chart. So that's why I mentioned here, plot is a predefined function that allows you to plot, I guess yesterday you might have come across all this, right? Data visualization. So I hope I need not to touch much on that because as it was discussed yesterday. Now I'm going to plot this, let's say pie chart, and further I need to add title for my chart. So I have used a title as one more parameter for this plot function, and which title that you are interested, you need to keep here. So here it is about plotting the occupation of the president. So that's why I have added this title. And different occupations that we observed in the data set, right? Few are lawyer, and a few are, let's say, businessman, soldier, actor. So different occupations they did. So now if you want to display according to their occupation, and of course different occupation, right? So you have to display that with different colors. So that's why I have created a list that includes different colors: yellow, green, gold, light sky blue, light coral, red, green, blue, orange, white, brown. So these are different colors I have defined. So automatically it takes the color. Now you can see here that I have assigned it in the name called colors. The same thing that I have used here in the plot that you can see here. So where I have defined here the colors with these defined colors mentioned in the above statement. So where it takes the colors and plots that accordingly. So where it counts, of course, that is what I have said. Value underscore count is a function that allows you to count, of course, based on the occupation. How many occupation is under, let's say, lawyer? How many occupation is under soldier? Let's say a businessman, and so on. So for that, this is used here, and in which you are supposed to apply is, let's say, this data frame with the parameter occupation. So in that, we are supposed to apply this and then show that. So let's say here I have used a matplot. PyPlot is what is used, and it is referred through PLT. So that is used here to show this. Now you can see that it will generate a pie chart, and the pie chart with respect to, you can see the output in the console where it has displayed the president occupation with different categories. So by this, we can, with this pie chart, we can do some inference. So let's say, for example, if you want to infer top 2 occupations of US presidents, we can conclude by this saying that lawyer and soldier. And third occupation, we can say, let's say, businessman. So likewise, you can do some small inference from this in this data set. So this is how you can make use of, let's say, pie chart and display these occupation, and you can do your analysis. So these are simple analysis. With the available data set what you have, you can bring into, let's say, as a data frame, and you can do your analysis with the help of the predefined facility available in Pandas and Matplotlib. Right. Now let us go for fourth analysis. So it is about popularity by president wise. So let's say which president has gained the popularity. What is the percentage of minimum popularity, maximum popularity? So for this, where you need to go for getting the frequency, right? So what is the popularity of the percentage? President by means of percentage. So for which I have used histogram charts. So now you can see here that I have used the same, where it is an extension of modified version of the previous code, that you can see that I have read that Excel file, which is maintained in my location, president Excel file. And I'm going to read this. So this statement helps you to read. I'm going to ensure you can also observe that in the data set, you have some missing values. And missing values are represented like this, not applicable, where I'm going to check whether is there any not applicable content. If it is there, where it should be replaced with 0. So that's why this is used here, to ensure that it is not being matched with that. So we are just taking the statement. And you can see here histogram charts is used. HIST is what you are supposed to refer for this. So this refers to histogram charts where you have to include, let's say if you are interested with respect to president, title, you have to include the popular. This is about popularity by president. So where it is included as a title, then if you want to add color, for that you can add what is the color you require. And beside that, I've also included whatever that we discussed in the previous case, like min and maximum percentage of the popularity of presidents. So in that context, I have included these two statements, min and max function, which we discussed in the previous example. Now this program is going to generate an histogram by which you can understand what is the percentage of frequency, what is the highest percentage of frequency. So that you can see here that this program has generated an output where you can see that in the bottom left corner, which is a console. So you can see that it has generated an output where popularity by president, right? So you can see and you can infer from this histogram that the president popularity between 47 to 50 is more in that data set, right? Comparatively with other popularity percentage of presidents, the popularity of president between 47% to 50% or with higher frequency, then followed by 50 to 53 and 53 to 55. So this is how the frequency existing in that data set. So this is how you can do your analysis with respect to fine. Participants, please respond. Is it visible? Right. So one of the participant, please respond. Is it clear?
Yes, sir.
Thank you. So this is how you can do simple analysis with your data set. Only a few cases I have taken here for the discussion. Like this, you can get the data set and you can perform various analysis and you can plot that and perform some small inference from this. So this is how you can do. So that's about first case study. The first case study is about, as I said, a president data set is available. We are going to perform, we did some analysis, like for example, analyzing the president by their occupation, years in office with respect to that president and minimum age, where further it was plotted in the pie chart based on the occupation, and histograms were used to measure the popularity by president. So this is how you can perform various data analysis. So for this, you can prefer pandas data frame and you can perform. So that is what I have adopted in my case. Now coming to second case study. So this is the case study that provides you the importance of statistics. So for this case study, the data set from Tennessee, a southern eastern part of USA. So students' performance data was taken from the public school available in that region. So this is, of course, in southern eastern part of USA. Now, let me give the summary about this particular problem. Sally is a public school administrator. So some of the schools in her state, that is Middle Tennessee, so where it has been noticed that some of the students are performing below average in academic. So in that public school, they noticed that some of these students are below average with respect to academic. Her superintendent is under pressure from the parent side. So that's the reason why his superior approached Sally to take this task in understanding why the students in the schools are, let's say, some of the students in certain schools are performing below average in terms of academic. So that is the assignment given by her superior to Sally. So to improve the performance, what Sally need to do is, so she has to understand the problems existing in the schools as well as students associated with the schools. So like how business problems are designed, where they try to understand, let's say when you are supposed to design a business model, the first thing that you need to do is you need to understand the strength and weaknesses existing. So ultimately it has to satisfy the customers and you need to get the customer base. That's what every business model will try to look for. Similar way, Shali also need to understand what is the strength and weaknesses existing in this particular scenario. So that's why she started this analysis. So this is like she started, let's say with some eagerness, she started to build an impressive explanatory model. But she understands that it's not going to give much of the required output or much of analysis, because there may be a chance that it may, let's say, possibly avoid or pitfalls or blind spots which are existing. So she understands the importance in that and she started doing it further. So not, let's say with the explanatory part of it, she further gone for exploratory analysis with various statistical features. So for that, what she has done is, before, let's say, doing this work or before initiating this task, she did a complete review. So the review, a complete detailed review she has undergone. On that basis, she collected the data that you can, and further, she has adopted descriptive statistics and also gone to inferential statistics and visualized the data for further inference. So this is what she has done in this particular case. So I'm going to show you the data set, what she has generated. So after a complete review and data collection, she could able to get sufficient data for her analysis. So it's only a sample collection. And this sample collection may be used to conclude for the entire population across that region. So for that, she has taken, she has generated the data based on the reviews that she has undergone. Now you can see here how she has undergone the review. So Sally has a strong opinion, of course, why some schools are underperforming. So though she looks to take some opinion, strong opinion from different academicians in that region with respect to that public school. But those opinions alone can't give you the complete facts. So these will not provide you a complete facts, or you can say a complete statistical evidence to say that this is the reason for that. So that's why she conducts a complete review uh, in order to understand what is the problem existing, as well as to familiar in that particular case where she did that. And further, she also try to look into wider part of the cases based on their income and based on their parental involvement, their curricula. So all these considerations was taken during or taken into the discussion during that review, and further she started for data collection. And for that she end up with a data collection. So like as I said, I can show you what is the data that she has generated. For a moment, I'll stop sharing my screen with respect to this Word document and move back to the Excel sheet where she got that data. Let me open my Excel sheet. Yeah, I hope it has displayed for you, right? So this is the data set what she has generated based on the review what she has conducted. And with the review, she has generated this sample data set. Now, after applying the statistics on this data, I mean, descriptive and inference statistics, she could come to some conclusion which can be applied for the entire population. So she has recorded, she has generated the data set with several parameters. For example, like name, name of the school rating, and then size of the school, then reduced lunch. So we are going to discuss this later, this parameter, because this has influence. Reduced lunch is a scheme where poor peoples were identified and they were given lunch in order to motivate them to come to school. So that is one parameter. So percentage with respect to that state. Then students students teacher ratio is another parameter. Then further, type of school. So three major types of schools in this case study. One is public magnet, and public cater. So these types of schools was taken here for the study. And what is the average score? Then full-time teachers. How many full-time teachers in that school? Percentage of people, let's say black peoples, and percentage of white, and percentage of from Asian countries. Likewise, percentage from Hispanic. So likewise, she has taken different parameters, and she recorded the data on that basis. So likewise, she has generated the data set, which is about, let's say, 348 records. So this 348 records comprises of sample data that covers, uh, let's say, different regions of that middle Tennessee region. So that state she has taken and she has generated the data. So this is a sample data set what she has generated for her analysis. Now further we are going to get into the problem. I hope you understood this data, right? So participants, I hope you could follow this data set, isn't it? at least one response so that I may proceed further.
Yes, sir.
Yeah, fine.
Yes, sir.
Yeah, thank you. Thank you for your response. So this is the actual data set, what she has taken for this analysis. And now, Shali finds the sufficient data available with respect to different parameters, and she retrieves. So now this has to be converted into an useful information. Of course, she has the data, but this data alone cannot help her to come to a conclusion, right? So she has to convert this data into a meaningful information. Means she has to find what is the insight existing or hidden in this data in order to come to a conclusion why some of the students are academically weak in that area. So that is what she is supposed to conclude. So for that, let me close this Excel sheet. I hope you could follow and understand in the remaining discussion with respect to this. Let me open that file with respect to case study. Okay. Now further, as I said, though she has the data, that alone is not sufficient. She has to get the hidden information from this data set. What Shali finds is two major statistics that could help for this case study. One is descriptive and inferential statistics. So she noted that these two statistics can help. Now let us see how these two statistics can help her to extract the meaningful information. One is descriptive statistics. About this two forms of statistics I've said, right? So descriptive statistics is basically used to identify the patterns existing in that data, but you can't make any hypothesis in that. It is only to identify some interesting patterns existing in that. So with descriptive statistics, you can able to perform two measures to describe about this data. One is central tendency and another one is deviation. So these two are popular measures used in descriptive statistics. So for central tendency, you can refer to the central position of the data. Like you can get the mean, median, mode. I hope you're aware about this familiar terminologies in statistics. If not, I'll brief on getting into that. So mean refers to the average value existing, and mode refers to, let's say, the most common number existing in that data. Median is the middle of that middle number of that data set. While let's say she adopts this to understand mean, median, and mode existing in that data set. So how far data has been spread, and is there any deviation from the mean? If it is deviation from the mean, how far the spreading pattern of data existing in that? So for that, she adopted this descriptive statistics. And descriptive statistics is also used to measure the deviation, that standard deviation. So standard deviation is a measure which is used to extract the information concerned with the data which are close to mean. Let's say when there is a small deviation existing, you can understand that the data are close to mean. And if there is a large deviation, so that indicates that data are, or let's say maybe widespread, more of the data are widespread and which is away from the mean value. So that's how it can be adopted for this descriptive statistics. So two measures that she has undertaken. One is central tendency, which is to understand the central position of the data by means of mean, median, and mode. And another one is standard deviation, that is to measure how the data is deviation from the mean position. So for that standard deviation, she has used in this. And further is inferential statistics. So this is basically used to generate or to infer certain meaningful information. This inferential statistics is used. So this is one that allows to make the hypothesis, that is to infer some useful information from the sample. Because this is not the complete data, only 348 records. So with that 348 records, we can't, it's not representing the entire region. Of course, it's a sample. So with this inference, she can conclude for the entire population of all the schools existing in that region. So that's how she can think of applying this. So for that, initially what she has done is she kept this inferential statistics and thought of doing it at the second phase. The first phase, she started doing this with descriptive statistics. Now I'm going to show how you can perform descriptive statistics, like how you can generate mean, median, mode, and also standard deviation for further analysis. So this can be used to understand some patterns or used to identify some patterns existing in that data, and that can be a base for making the hypothesis in the next phase. So I'm going to close the screen and move back to the program environment, how you can develop the code for this and how you can write the code for this.
విడిచిపెట్టి విశ్వాసంలో కర్తయ్య దాన్ని కొనసాగించుకొని ఏసు వైపు చూస్తూ ఆ ఎదురు ఉంచబడిన పరుగులను లోతుపెట్టి పరిగెత్తం అంటే ప్రతి భారమును మీరు విడిచిపెట్టండి.
I have opened my programming environment. So data set which is maintained, as I said, right? This is openly available data set. So this is where I have taken this. Even you can also use to directly read from the website, or you can maintain in an Excel and you can open it from your system. So here I have maintained in my system, and from where I have opened it. The above instruction you can use to directly even read, but you should know where the path that data set is available. So if you provide this path properly, then you can also read your file maintained in the form of CSV, and you can use it for your analysis. But here I have read this through the path maintained in my local machine. So first what I did is I've used let's say read underscore CSV. So this is a predefined facility available in Pandas to read a CSV file. And after reading that, where it is assigned to let's say DF, representing as a data frame, of course it's a tabled format where it maintains. And describe is a predefined method to describe about that particular data that has been read from the CSV file. And further, you are going to group this based on two things. One is reduced lunch and school rating. So initially, while doing the review, she noticed that there is some sort of impact in this two parameters. That's why she was very much interested, or she's very much keen to focus on these two parameters. Similar way, in your measures, you can also go for further parameters also. But in this case study, only these two parameters has been observed that it is influential in, let's say, getting that results. So that's why these two parameters alone has been taken from that data set. And here it is to understand, let's say, the correlation existing between these two. So means when there exists a positive correlation, means when there is an increase in reduced lunch, school rating should also get increased. And when there is a decrease in reduced lunch and when there is an increase in school rating, it is a kind of negative correlation. Are you getting this? Means the values are 1, we can say as positive correlation, and when it is moving away from 1, negative values, then we can say it as negative correlation. Means when there is an increase in school rating, the reduced lunch will get decreased. Or when the reduced lunch increases, the school rating gets decreased, the negative effect. So where we can say that it's a negative correlation. And further, we are going to use box plot to plot this. So first, let me show you the output for this case. Up to now, what we discussed, let me generate and show you the output. So from this, the output has generated. Now, what I did is I've just used to describe this function in my code. So by which it could describe the information on this way. Total count. So if you exclude the header, so 348 records we observed, right? One record is concerned with the header information. So total number of records is 348, and the mean value, this describe function itself will try to generate all this with respect to school rating. Likewise, all the parameters you can see it will try to generate. But here in our case, we have limited, right? And you can see here what is the mean value and standard deviation, minimum, and you can see and you can come to even conclusion whether from mean value is it deviating much or is it smaller deviation. So when it is deviating much from the mean value, you can let's say see that there is a large deviation in the data set. Means data set are not closer to the mean value. Instead, it is widespread of the values existing. So that's what we can conclude. So minimum value is 0. At 25% of the data, it is 2. 50% it is 3. 75% it is 4. Maximum value is 5.
तो सर बोले उसको ऑनलाइन.
Hello. So this is how you can use to describe your data. And further, we grouped according to only this case, like as he said, right? In the next case, we grouped it only with respect to school rating. So with respect to these two parameters alone, we have taken reduced lunch and school rating. So these two parameters are grouped according to school rating, and the description is given over here for that. And that is what you could see here. So this is with respect to school rating and reduced lunch. And further, a correlation has been, CORR is a predefined facility available to find the correlation existing between these two parameters, reduced lunch and school rating. So if the correlation matrix you could see here, right? So you can observe that between reduced lunch and school rating, there is a negative correlation, right? So this indicates that whenever if there is any increase in reduced lunch, if the values are getting increased in reduced lunch, school rating will get decreased. Means more, students are let's say are given with lunch. So due to poverty or any other reasons we can say. So which means that impacts on their academic performance. So when there is more poverty existing in that region, so it means the school rating is getting down. And when there is decrease in reduced lunch, when let's say when the government is offering only minimum lunch for the students, that indicates that the poverty is less, and in fact, impact is on school rating. So school rating increases. So this is how it creates an impact in this. So with this, it is possible to understand that there exists a negative correlation between reduced lunch and school rating. If it is, of course, closer to 1, we can say, or 1, we can say it is a positive correlation. But now it is a negative value that indicates that it's a negative correlation. Similar way, when there is a increase in, let's say, school rating, reduced lunch is getting decreased. So this is how it impacts on each other with respect to change in the value. Of course, she has identified that there is a negative correlation existing, but still to infer more information, inferential statistics is further, like different data visualization tools has been used here to go for further analysis. So by which I'll just close this for a moment and move back to, let's say, the file to show you how so all this is what I have discussed so far, and the output what has been generated, I have discussed it. So further, she noticed that the reduced lunch and student rating, the values in the correlation matrix, generally when you use correlation function, it generates the value between -1 to +1, and -1 indicates there is a strong negative possibilities for correlation, and when it is 1 indicates, of course, it's an opposite. For further relationships to understand existing between, she has used box and whisker plots for understanding that, and then you can use scatter plots also to understand the relationship existing. Of course, this is second way of analysis, and third one is correlation matrix. So I'm going to show you how it has been generated and what kind of inference you can do it with respect to these plots. First one is box and whisker plots. So now you can see here, this is between school rating and reduced lunch. You can see that whenever if there is a reduced lunch, the school rating is closer to mean value. You can see that somewhere it is in the middle. And whenever if this reduced lunch increases, you can see that it is moving away from the mean position. It's not, let's say, in the mean position. So these are the inference what you can do from these box plot. And further is heat map. You can also again do the same analysis with respect to reduced lunch and school rating. So you can see that a linear line drawn here, you can see whenever if there is a reduced lunch, it is very closer to this, very closer to the mean value. But whenever if mean, if there is any increase in reduced lunch, you can see that there is a wide spread of rating. So these are the inferences what you can do, and statistically you can prove this. And further heat maps, you can also see here the heat maps, and further you can extract some inference here again with respect to each and every parameter, right? With respect to school rating, what are the other impacts beside, let's say, reduced lunch? What are the other impacts? So red color, you can see that it's a kind of, or that particular parameter will be more influence on school rating. Similarly, size, reduced lunch. So likewise, you can do this, of course, you can generate a correlation, I mean, heat maps with this, you can able to compare each attribute with another attribute. So this is how you can perform a further analysis, not restricting to only to this inference. Further, you can also go for other set of statistical tools by which you can go for further inference for this. So let me conclude with only up to this. Even further more analysis can also be done. But Shally found that she got some statistical proof that whenever there is an increase in reduced lunch, the school rating decreases. And whenever if the school rating increases, there is a reduced lunch. I mean, a decrease in reduced lunch. So this is how you can perform your analysis more statistically with sample data, and the same results can also be applied for a large population. So that's about a second case study. Now we'll go for third case study, which is about heart disease prediction.
அவனுக்கு வருதுமே வருது இல்லடா
Sorry.
So there's no slide, sir.
Yeah, now you could see. I hope you got it now, right? The third case study is how to use machine learning algorithms to perform your analysis. So for this, a popular heart disease data set, Cleveland heart disease data set from UCI machine learning repository was used for this case study. So this data set consists of 76 attributes. Though it includes 76 attributes, not all the 76 attributes are necessary for analysis. So most of the researchers have used only 14 attributes. So 13 plus 1, as I said in the morning, right? Supervised learning models requires class labels. So 13 is the parameters associated with heart disease data set, and 1 is the class label. So that is used in this case for heart disease prediction. And last 14th attribute is a target attribute. So that includes the information about the presence or absence of the heart disease. And integer value between 0 to 4 is represented. When it is 0, it indicates that it is an absence of heart disease. And when it is 1, 2, 3, 4, it represents that it is present. So that is how the data set is available in that repository. And that data set was actually used for prediction. So the prediction is about what is the accuracy of the prediction. That way, the case study was analyzed. Now let me move to the programming environment to show how you need to code and do your math with the help of different machine learning algorithms. Now for this, as I said, 13 plus 1. These 13 attributes which are available here, like age, sex, chest pain type, let's say blood pressure, cholesterol level, fasting, let's say blood sugar level, resting blood pressure, thallium scan, cold peak, let's say colored vessel fluoroscopy. So these are different parameters used for this analysis. Those 76 attributes are available, but 14 attributes has been taken for study by many researchers. That's why in this case also it is only with 13 attributes. And the last attribute is target attribute. And that target attribute refers to the class label, right? Now you can see here how we are defining the target label. When it is, as I said, right, 0 means absence. 1, 2, 3, 4 is absence, presence of heart disease. When it is 0, it is absence of heart disease. When it is 1, it is presence of heart disease. So where it is given here, like when it is 1, 2, 3, 4, it is represented as 1 for easy analysis. Means when it is 1, it is referred as presence. When it is 2, it is again represented as 1. When it is 3, because all these are indicating the presence of heart disease. So this is how the target field has been replaced with zeros and 1. 0 indicates that it is present, absence of heart disease, and 1 indicates that it is presence of heart disease. And in order to let's say extract the information concerned with male and female patients existing in that data set, where it is extracted on this basis, and also based on the mean value for thallium scan, and also to get the mean value of color vessel fluoroscopy. That is one of the parameter in that heart disease data set. It has been used for this study. And first is to understand the distribution of the patients with respect to age. Let's say to understand how the patients are distributed with respect to age. So for that, just want to show you where you could understand that. Graphs is used here. So this refers to particular age group and the target case. Now you can see that so this age group, let's say somewhere between 58 to 62, or you can also take a wide range between, let's say, like 40 to 60 or more of with, let's say, presence. Right? So between 29 to 77, that's the variation they have taken in the study. And here you can see presence and absence of heart disease. So to understand how the distribution with respect to age, you can use this plot and you can understand the data set. For example, here count is used, so where it will count with respect to age and also with respect to let us say that target, and you can sort out this value, only unique value will be taken, and order that according to age. And this is to display the title and where it shows how the distribution of the target variable with respect to age parameter. And next one is bar plot is used here to represent with respect to male and female ratio. So that also I'll show you here. How the distribution of this presence and absence of heart disease with respect to male and female candidate. So that you can see here. Right. So now some inference also we can do with respect to this. Let's say with this male and female, we can come to a small conclusion that male are getting affected in lesser age compared with female. Now you can see it is closer to 60. The mean value is closer to 60 with respect to age. But now you can see here, male are vulnerable to heart disease earlier compared to female. So likewise, you can do some analysis based on this distribution, right? So beside that, if you want to apply, so this is a simple analysis what has given here with respect to distribution of age and distribution of age with respect to male and female. And next further we go for applying different machine learning algorithms. And let us try to see how each algorithm predicts the disease and which algorithm is better compared with other with respect to this data set. Now further, we'll go for data pre-processing. So data pre-processing is used to just remove any noisy values present in that, or simply to say, prepare your data before you apply your analysis. So for that, we are going for data pre-processing. And again, sklearn, let's say features were used, and now we are going to separate this data set with training and testing in terms of 80-20. 80 is your training sample. With the available total sample, 80 is taken for training and 20% of data will be taken for testing. So to represent that, this is used 0.2 refers to 20% of the available data will be taken for test, and remaining 80% will be taken for training. So that 80% of data is used to train your model, and based on the training that has received, where you go for applying your supervised learning models to classify whether a patient is affected or not affected, and further to calculate the accuracy of the classification with respect to that disease. Now, whatever is being generated here will now get stored like training and testing information in terms of 80 and 20. So for better accuracy, you can go for 80-20, or even some of the models can also be given with 70-30. It's up to you how far you are looking for a better performance. Now, first one is about SVM classification. So different algorithms that I have used for this problem is SVM, Navy Bayes, logistic regression, decision tree, random forest, and then extreme boost, gradient boost. So these algorithms were used for, these machine learning algorithms has been used for this data set for prediction. So first one is SVM. For all this, you have predefined libraries. You need not to write the code, only with minimum efforts. So when you consider here, SVM classifier, which is used here, kernel you need to define, let's say, which type of kernel. Likewise, only a minimum input you need to provide here. And then you can go for, let's say, generating the confusion matrix to get the accuracy existing over there, where you can write the formulas for, let's say, accuracy to generate or testing and training samples. Likewise, it is being carried out for all the algorithms with respect to Navy base, with respect to logistic regression. These are algorithms used for supervised learning models, right? When I'll be sharing this code, which was taken for this case study, you can also attempt and see and try to understand how these algorithms performs with respect to this data set. Now you can see here, the accuracy generated by different algorithms has been mentioned over here. Testing samples we see here, 80% accuracy generated by SVM, then 78%, and here 80.3 to almost SVM and logistic regression are performing equally in this case. And compared with all the algorithms, you can see that random forest is performing, it's not performing equal to other algorithms. So that is how you can also perform a comparison with respect to different data set, and you can come to a conclusion, like which machine learning algorithm will be suitable for this data set. So likewise, you can adopt different machine learning algorithms that is feasible for your analysis and also provides a better performance. So this is how you can take different, of course, here I have taken only one data set. You can apply for different data set and also compare, and you can come to some conclusion which algorithm performs better. I'll show you the data set and we'll move to last case study followed by this. I have opened this. Could you see this data set? If not, I'll try to briefly describe this. As I said, it includes 13 plus 1. 13 is the parameters used for diagnosis of heart disease, and 1 is a target attribute, and this target attribute will range between 0 to 4. And as I already mentioned in the beginning of the case study, 0 is considered as absence of heart disease. 1, 2, 3, 4 values are considered as presence of heart disease. For supervised learning models, you require a data set which consists of class labels. Only with the help of these class labels, where you train your model, that could understand the patterns existing on that basis. And when you provide a new samples,
Sir, screen is not visible.
Yeah, I have opened it. It's taking time, I guess.
Yeah, thank you.
I could see it on my mission. 1 second, ma'am. I hope now you could see.
Yeah, it's visible, sir, now. Thank you.
Thank you. Thank you. So as I said, right, 13 parameters: age, let's say sex, chest pain type, and further, let's say cholesterol level, fasting blood pressure, and so on. I mean, blood sugar level, blood pressure. So all this has been measured and placed here. So observe the last attribute, which is a class, target class, which is going to represent presence and absence of heart disease, where the values are ranging between 0 to 4. So you can perform a supervised machine learning provided if you have this class labels. That's why it gets that name, supervised machine learning. In case if you don't have this target label, but still you need to perform your analysis, then you should go for, let's say, unsupervised learning model. Now, another thing you can also observe, in some cases, let's say, some of the algorithm does not support to accept this value as such. For example, few algorithms may work between 0 to 1, or let's say it requires some floating point value between 0 to 1. Some continuous values is what it takes as an input. In such cases, you have to transform your information into the values that could fit between 0 to 1. So transformation algorithms you have to use. Like you need to go for normalization. So like min-max normalization, Z normalization. So where you have to apply different normalization and bring down your values that could fit between that range. So whatever may be the range of values, so where you have to use normalization techniques like min-max normalization, Z normalization. Likewise, you have several normalization technique. Based on the one that is suitable to your data set, you can adopt and you can transform your data that could fit between the defined range, which will support for that algorithm to do that analysis. So this is how you can do. So that's about this third case study. So third case study is about prediction of heart disease based on Cleveland heart disease data set, where different algorithms has been used in this case, like SVM, Navy Bayes, logistic regression, decision tree, random forest, and extreme gradient boost. So 6 algorithms has been taken, of which you can come to a conclusion that SVM and logistic regression outperforms compared with the other algorithms existing in this analysis. So I'll move to the last case, where I'll go for last case study that is about unsupervised learning, where I have taken k-means clustering to demonstrate.
मेरा सर्टिफिकेट चला जाएगा याद ही नहीं रहा
I have taken directly the data values and I did it. I'll be showing you how you can apply k-means for this. I hope you could get my screen. So instead of taking from Excel, directly the values has been randomly generated here like this. And it is converted into data frames representing 2 columns, X and Y. And further, you can go for defining the number of clusters in which you need to adopt for k-means. So k refers to how many groups you are supposed to cluster this. So how many groups you are supposed to form this distribution of data. So where you can use here k-means a predefined library available here, and to which you need to pass only the number of clusters, means how many groups that you are supposed to form with respect to the distribution of this data set. And then a scatter plot is used for placing this distribution, how far it is distributed. Now, for example, if I run this code, you can see that what I did initially is to simply, where I have displayed this with respect to data set. And here you can see there is no target class to train your model, where the algorithm what is adopted itself should try to get the patterns existing in that. On that basis, where it should go. So k-means clustering is used here. So based on initially it selects the mean value randomly available in that distribution of data set, and further it goes for iterating it. On that basis, it segregates, let's say, based on the number of clusters which is mentioned. Now you can see here that I have displayed the distribution of these values with respect to different ranges. Now, as we said, in 3 groups, it is supposed to be categorized. You can see one group falls under this, and this is another group, and further, this is the another one. Now, you could see that none of the data is in between this range. So you can also even change, let's say, if you want to change the number of clusters into 4, you can also replace that k value 3 by 4, by which it groups that into different categories. Now you can see that a new scattered plots I have generated here with 4 groups. So k is given as 4. So it groups that into 4 groups. This data will be getting distributed in 4 groups. Now this is about one group, and this is another one, and here it is another. And again, we could see that none of the case falls under this group. So where initially it performs, let's say, by selecting random selection of the mean values based on the k value, and then the process iterates. On that basis, it will try to redistribute the values between these based on these groups, and then at last where it stops its process when further there is nothing to redistribute it. So the algorithm ends over there. So this is how k-means clustering works. Now what I like to say here is you can adopt like this without, you need not to write a complete code, with a minimum efforts where you can write your machine learning algorithms. Even you can also further extend, in case if you want to extend it further. Let's say if you want to improvise k-means algorithm, then in which particular case or in context you are going to improvise, redesign your algorithms, and you can proceed further. So this is about a 4th case study, how you can perform unsupervised learning. And I have taken it only with data that has been distributed directly here, and it was taken in a data frame and taken for this analysis. Now further, I'll just try to show you only one interesting case, how WHO has used various data science features for this COVID-19 analysis, and by that we'll conclude this. course, some of you might even visited this site, but still I feel it is interesting to share for some of them who has not already visited this website. So WHO is doing a lot of analysis, and it has given the information in this website with respect to COVID-19. So here we could able to get a lot of, or we can even, you can also see here, there is a link given here to download. You can get the complete data where you can download that in CSV file. So you can see here, download. So if you click, you can able to get the, you can see here, complete global data is available with respect to each country and various information like when the first case was registered and let's say how many new cases in a particular day and what is the total death. So likewise, they did, I mean, they have gathered the different information and they have given it here. You can also use this for your analysis. Very well, we can do. So of course, it is about 78 MB or something between 70 to 78 MB. So it's worth to take this data set and do various analysis. Quickly, I'll show you what kind of information they have given in this, let's say, dashboard. So now you can see here, simply if you keep navigating to different countries and regions, you can see that information are given concerned with how many cases registered and how many deaths, confirmed cases on a particular day, deaths and so on. So beside that, you can also see the trends which is given here with respect to the confirmed cases and deaths. And beside that, you can also get various information. So with respect to daily report, weekly report has been given here. They used different plots like box plots, scattered plot. So they use different plots. Of course, you can also use here. And also you can see with respect to different dates. So this is how you can do even your analysis. You see how interestingly they have done this analysis and has given a more interesting information in this website. So this is with respect to confirmed cases global wide. Even with respect to country wide also, you can able to navigate and see. So the complete data is available here. You can download the link I have given here, right? I mean, the link given in this website, I have mentioned it, right? So you can download, it is about 70 plus MB data content. It is worth to extract more information from this data set. And with respect to region, also you can see, here, death cases with respect to daily cases or in which particular month. So these are some interesting facts where we can able to get, and on that basis we can even do our analysis, and even we can convert this into research papers also. Based on our findings and conclusions, we can even convert this into research papers. And even you could observe several research outcomes based on this data you could see. Very excellent information they have given here. And also they have shared their data set. We can even see here. Even with respect to country, you can see. And you can see here in which date the first case was registered. We can see sometime in the month of March, right? And when the peak, let's say, it is about in the month of September, around 94 cases. So likewise, we can able to get some meaningful information from this website. So this is what practically the business organizations or business companies will try to do, their analysis, and try to get some useful insights from this information, right? Even I'll also try to show you how they have this data set. So this is about that data set. You can see with respect to country code, country, and let's say the cases, cumulative cases, new death, cumulative death. Likewise, they have given this data set for the global wide data. Even you can extract based on the country, based on the region, or based on a specific date. You can simply do your analysis with the help of this data set. So similarly, you can also go for other interesting websites like Google Trend, where they too maintain based on the searches performed in Google search engine. They also have given some interesting facts where you can try to see more interesting informations there. So that's all from my side today. Now it's a time for clarifying your queries. If you have any queries, you please raise your queries so that I could able to satisfy your queries.
Any queries, any questions from participants?
Hello, sir. Good evening, sir.
Good evening.
Myself Balakrishna from Andhra Pradesh.
Yeah, welcome, sir.
I am doing research on brain emotional recognition, sir. Brain emotional recognition. Easy. Brain,
Okay.
human brain.
Okay, human brain. Okay, sir. Tell me, sir.
Emotional recognition and classify the diseases. Various disorders are there in the human brain.
Fine, sir.
Suppose I am interlinking COVID with respect to EEG. Is there any database available nowadays?
Sir, it is right now, of course, only preliminary data like this is available now. Still, the pandemic situation is existing. In the months to come, we could see more data will be available. Of course, this is only from WHO. Besides that, there are other organizations who also provides the data concerned with COVID. So even it could be an interesting study. You can also see how it impacts on how COVID pandemic has impacted on human emotions. Very well, it could be a good study. One is you have to see a suitable repository where you can get the data, sir. That's a challenge. Of course, getting the data is a challenge here. So you have to find out or keep tracking various resources that provides COVID data. I have given you one sample where you can get the COVID data. It is about 78 million, and even with respect to countries also you can download. But here I could not see that could match your requirement like emotion related parameter. You can keep track on different repositories, sir, where they register even with respect to human emotions. Or you can also collect data if possible from our local hospitals. But present situation, I hope, may not be possible. But still you can search for repositories, sir. Really, it could be a good study. Really, from my view, really, it could be an interesting study. But getting
Sure, sir. I am also waiting for that only, sir. In this pandemic situation, we are not moving from hospital.
Yeah, that's what.
At home only.
Situation still does not allows you to go to hospital and get this. But still, you can keep track on various repositories where they openly share the data for researchers. If it comes to my knowledge, sure, I'll try to share, let's say, through even I didn't visited with respect to your requirement. If possible, within 1 or 2 days, I could do some search from my end. If possible, I could get, I will share it to you, sir.
Excuse me, sir. Good afternoon, sir.
Yeah, good afternoon, ma'am.
Sir, please explain L1 and L2 regularization. What is this, sir? Means what is this hyperparameter and how it affects the accuracy?
Ma'am, these hyperparameters, whenever if the hyperparameters are generally used to separate the data set in two different classes. For example, when you take SVM classification, we use this parameter, hyperplane to separate two classes by which you can widen the length of your, of course, you can widen the width of your hyperplane by which clearly you can separate the classes like positive and negative cases, or let's say affected and unaffected. So this can help you to categorize your class labels correctly, like affected as affected, unaffected as unaffected.
Sir, I am asking about L1 and L2 regularization. This, what is this, sir? Actually, I don't know regarding this.
I thought it is hyperplane.
No, sir. L1 and L2 regularization. I'm asking this, sir. Please explain.
Lasso regression, sir. Yeah, lasso. L1, L2.
Okay. No, ma'am, I don't have idea right now.
Okay, no problem, sir.
I could able to provide you some information through convener, or if you provide the details, I can able to share.
Okay, sir. Thank you, sir.
Thank you.
Sir, once again, I
No,
can
one more
interrupt,
person.
sir.
Yes. Yes, sir. Yes, sir.
Sir, it is possible to me to interlink COVID-19 as well as emotional brain.
Sir, I'm not getting you.
It is difficult to for me as well. It is go through easily COVID-19 interlink with emotional brain, emotional recognition.
Sir, it is possible provided if you have some parameter that could link with your study. But still you have to wait for some time, or you have to wait for standard medical repositories where they commonly share the data. Like you can search, keep on track with these repositories. If you could able to get, maybe your study could be interesting.
Thank you, sir. Appreciate your details, sir. I will contact you.
Sure, sure, sure.
Thank you, sir. Very good information session, sir.
Thank you, thank you.
One more participant is raising the hand. Lily Grace Mary.
Yes,
You
sir.
can ask the question. One participant is raising the hand. Kotapuri, Lily Grace Mary. Any participants? Any more questions?
Sir, after finding out the accuracy, how to validate the model, sir?
Accuracy is one of the parameter.
No, validating the model, how we can validate whether we have to take the again new test data and check. If it is doing good, then it is correct. Or any other way is there to validate?
Now, one is accuracy alone is not the measure. You have sensitivity, specificity, misclassification rate. By combining all these measures, you can come to a conclusion. That is one way. The another way is, of course, what is available with the available data set, you are doing your analysis. But in a typical analysis, you have to train your model with your available data and a new sample that you are going to supply as an input, where it has to predict, and based on the classification accuracy that you got with the existing models, the same way you have to test. That's a way to validate.
One more, Srinivas is, Dr. T.R. Srinivas is raising the hand.
Yes, sir.
Yes, please go ahead, sir. I think the participants are hope getting the proper reply and response from the feedback. And I have already shared the feedback. Please fill the feedback carefully. Any more participants? Any questions?
Once again, I ask a question, sir.
Yeah, yes, sir.
What is the difference between one-hot encoding and label encoding?
One.
Hello.
Yes, sir,
Hello.
please.
Hello. Hello.
Hello.
Yes, sir.
Yes, response.
One-hot encoding and label encoding difference.
Sir, your please repeat it again, sir.
One-hot encoding and label encoding.
Label encoding and if you can text me, I could able to respond, sir.
I think question is not clear.
No, I could not get the question, sir. One.
I think the participant is making silence, not responding.
Difference between one-hot encoding and label encoding, sir.
Label encoding is like supervised models will generally get it through this label data. So that is what we can say. One-hot encoding. Even I'm not exactly aware, sir. I'll try to get it for you.
Thank you, sir.
So already I have shared the feedback. I think hope all of you fill the feedback form carefully. So please, if you need, you can copy paste and you can just or you need to click here itself and get it. What you call you need to fill up and carefully and submit the and we take the response. All the participants are giving full cooperation and with lot of interest they have today listen the classes and as well as this online session and our honorable Vivekanandan sir has explained and I say special thanks to Professor Vivekanandan T. So once again, so thank you very much, sir.
Thank you, sir. Thank you for your consideration and for giving me this opportunity. I thank everyone for patiently waiting for getting the screen. Some sort of moving from screen to, so that happened, but patiently they have listened. So I thank all the participants.
Thank you, sir. Thank you all participants. So morning session tomorrow is the industry person is coming. That is from company and corporate and industry person. So all of you be in time and before 10:30, 10 minutes before 10:30. So please join to the class and we will share in the morning in the group the session. Thank you, sir. We are closing the session.
Yes, sir. Thank you.